Hi guys, let's do palindrome linked list. So we're given the head of a singly linked list and they want us to return true if it's a palindrome or false otherwise. And for those of you who don't know, a palindrome is just a sequence that reads the same forward and backward. So this reads 1, 2, 2, 1. If we reversed it, then it would still be 1, 2, 2, 1. So that's a palindrome. So in this case, in example 1, we return true because it is a palindrome. And then in example 2, we return false because it's not a palindrome, because if we reversed it, then instead of 1, 2, it would read 2, 1, which is not the same. So for this one, we're going to want to first use a fast and slow pointer, where the fast is going 2 nodes at a time and the slow is going 1 node at a time, so that when the fast node reaches the end of the linked list, the slow node will be at the middle node. And then we can reverse the second half of the linked list. And then once we have the reversed second half of the linked list, then we can go back through and traverse both the first half and the second half at the same time and compare their values to check if they're the same. So if we have 1, 2, 2, 1, just like in this example, then once we reverse this, then this is going to, because this 2 is where the second node in the middle, so we're going to reverse from here on, and then this would be 1, 2 instead. So then we could traverse through starting from this point and this point and then check if the values are the same. So then the next iteration would be comparing this one to this one, and then when we reach the end of the list node, then like that's it. So that's how we're going to do that. So we're going to first start off by making our slow and fast pointers, and we're going to start them both off at the head, which in this example is 1. And then we need to iterate through and just increment them both. So while fast is not null and fast.next is not null, then we're going to move slow by 1 node at a time and fast by 2 nodes at a time. So then once we're done with that, then if we use S for slow and F for fast, our slow node will be here and our fast node will be out here, which is null. That's when we exit the loop. And then, so once we have that, then we need to reverse the second half of this linked list. So we want our slow to be reversed, and then I'm going to make a private method to reverse that node. So if you guys haven't watched my other video, I would watch that one first because I go more into detail about how to reverse a linked list. But oh, and I'm going to actually just do that. Okay. Okay, so that's our reversal method, and then once we reverse it, then our slow, because will basically be, we'll basically have this where slow is pointing at this 1 instead, and then fast is still pointing at null out here. And then, so because slow is pointing at the head of this linked list now, we'll just reassign fast to point at this node, the head of the other linked list. So we're going to reassign fast to head again. And then we just want to loop through both of these linked lists at the same time and check their values to make sure they're the same. So while slow is not null and fast is not null, if their values are different, then we're going to return false. And then we're just going to move them to the next node. So then once we reach the end of the linked lists, if we do not find any nodes where the values are different from each other, then it's a palindrome, so we can just return true. So let's submit. Okay, and then the time complexity, let me get this out of here, is O of n, where n is the number of nodes in our linked list. And that's because, so if we think about our algorithm here, we first had our slow and fast pointer, which iterated through the entire linked list once. So it's visiting each node once, which is O of n. And then, which is also this while loop here. And then our reversal method is also O of n because we iterate through every single, like we visit every single node in the second half of the linked list once, which is basically O of n over 2, which simplifies to O of n. And that's in this while loop where we visit each node. And then after we reverse it, then we traverse the second half and the first half at the same time to check their values to make sure that they're the same, which we do in this while loop. So that's also, we're also visiting every single node once, just simultaneously. So that's also O of n. And so all of this simplified, like O of n plus O of n plus O of n just simplifies to O of n. So that's our time complexity. And then our space complexity is constant because we just have like a few list nodes here that we initialized, and same with down here, but no data structures or anything like that. So that's it for this problem. Thank you guys for watching, and I'll see you guys next time. Bye.